All right, so number 9. At time 0, K is deposited into fund X, which accumulates at a force of interest, this one. At time M, 2K is deposited into fund Y, which accumulates at an annual effective interest rate of 10%. Okay, so first we have a force of interest and then we have an annual effective rate. At time N, where N is greater than M, the accumulated value is 4K. So let's draw the time diagram. At time 0, we have K coming in. And at time M, we have 2K coming in. And then at time N, the accumulated value is 4K. So you have to find M. Very interesting. So there are 2 deposits coming in. So let's see what's happening to this first deposit. So the K accumulates to so tell me, K is the principal. So since it's undergoing force of interest, so you know the formula for force of interest is this one, P E integral 0 to N in this case, because the total time it's deposited at 0 and it goes until N. So the total time is N, right? Between 0 and N, the time is N. So you go 0 to N and then force of interest dt. So that's the formula. And so the principal here is K and e power 0 to N, and delta t is 0.006 t square dt. So what's the integral of 0.006 t square? Zero zero six t cubed by 3, right? Okay, equals K e to the 0.002 t cube from 0 to N equals K e to the 0.002 N cube, and the lower limit is 0. Okay, this is what the K accumulates to. And what about this 2K? The 2K is coming in at this time. So how much time duration does it have till the end? It comes in at time M, and we want our final destination is time N. So how much duration do we have between this M and N?
N minus M.
N minus M. So the 2K accumulates to so this one is undergoing just a normal annual effective interest rate of 10%, which is compound interest. If by default everything is compound interest unless mentioned otherwise. So, so the formula is, what's the formula for compound interest? P 1 plus I power t. Yeah, that's the formula. So the principal for this one is 2k, and it would be 1 plus 0.10, and we agreed that it sits for n minus m time. So that will be 2k 1.1 power n minus m. So that's 2. So we have seen what both of them accumulate to. K accumulates to this one, and the 2k accumulates to this one. And we also know that the final accumulation value is 4k. So since the overall accumulation value is 4k, so the sum of these two has to be 4k. The first one was ke 0.002 n cube The second one was 2k 1.1 power n minus m. That's equal to 4k. Now the k can cancel out. You can divide everything by k. So you get e to the 0.002 n cube plus 2 times 1.1 power n minus m is equal to 4. And what is some other condition that we are missing here? Because we have to find m. So the only thing I can do from here is to get m in terms of n, isn't it? So see if that's what they have at the back. Look at the answers. So sad. So see if the answer is in terms of n or not. See, it's not even a calculator question because you were the phone. So all I was saying is look at the answer at the back.
Which one's this?
Yeah.
I'm confused on how k plus 2k equals 4k, because when does that equal 3k?
No, I didn't say k plus 2k is 4k. I said this whole thing plus this whole thing is 4k. Because they tell us that the accumulated value. Oh, the accumulated value of each fund is 4k. I thought the total value is 4k. Okay, that's why. All right. So not the overall accumulation, since the
Because it gives you a number.
right, because otherwise you can't get a number, right? Since the accumulation of each is 4k, so the first one is equal to 4k and second one is equal to 4k, right? Okay. So the first one is k e to the 0.002 n cube. That's equal to 4k. And the second one is also equal to 4k. And the second one was this one, 2k 1.1 power n minus n. So let's say this is 3, and this is 4. So now from 3, what do we get? Now divide out by k. So e to the 0.002 n cube is equal to 4. So now do we have enough information to get n from here? Yeah, take ln. So 0.002 n cube is equal to ln 4. N cube is equal to ln 4 over 0.002 and would be ln 4 over 0.002 power 1/3. So what do we get for n? How much? 3.02?
No, no. 8.8499.
8.85?
Yeah.
Okay. All right, that's good. We got n. And now let's look at 4, equation 4. So this is what it is, again, divide by k. So from 4, so we can divide out by k. So we get 2 times 1.1 power n minus n. Is equal to 4. Yeah, divide both sides by k. And so yeah, Emily, what you were doing was you were thinking that okay, k is deposited at 0 and then 2k is deposited, so the sum should be 3k. You were forgetting the interest because k was growing over 4 years to something else, and the 2k also grew over. Over n years to something else, and the 2k also. Okay, so from here, what should we do to solve for n minus m? Divide by 2 first. Get 2, and then take the ln. So n minus m is equal to ln 2 over ln 1.1. So how much do we get for n minus n? Yeah,
7.27.
7.27. Okay, and we already have the n. N is 8.85. So substitute that, because remember the goal is to find m. So m would be 8.85 minus 7.27 is equal to 1.58. Okay, that's what it is at the back.
1.58.
Yeah. Okay, good problem here. It looked as if everything is letters, but somehow we got a number. Okay. So after 9, next one is 11. And this is an SOA problem. All right. 11 is a beautiful problem. I don't know if 9, it has a double dagger with the 9 also, which means that at least at one point it was an SOA problem. I don't know if it is anymore or not. I don't remember having seen it, but it may be there. But this one I know for sure because I just saw it 2 days ago. Okay, so let's look at this. Ernie makes a deposit of 100 at time 0, so number 11, and X at time 3. The fund grows at a force of interest of this much. The interest earned from time 3 to 6 is X. Calculate X. Okay. So, okay, I'm not sure if it was exactly this problem or a slight variation of it. I think it was a slight variation that I saw on the SOA, but that's okay. So at time 0, you deposit 100, and then X at time 3. Deposit X, and then 6 is the next time of interest. Okay. The amount of interest earned from time 3 to time 6 is X. So normally, how would you calculate the amount of interest between 3 and 6?
Effective amount.
Shouldn't it be the amount at time 6 minus the amount at time 3? That difference will be the interest you gain from 3 to 6, right? So interest from time 3 to 6 is A of 6 minus A of 3. Okay. So the amount formula, this time we have just force of interest going on. So the amount formula A of t under force of interest is how much? Tell me.
100 times E and the integral.
Right. So in general, it would be P e power integral 0 to t, yeah, delta t dt. So once again, the 100. So first of all, 100 is deposited at time 0. So the approach will be, first we will see what happens to this 100 by the time 3. Because then at time 3, other things are happening. So first step is to see how much this 100 accumulates to by time 3, right? So 100 accumulates by time 3 to, so now we will have 100 e power 0 to 3, and delta t is t squared by 100. Force of interest is very prevalent. If you look in the SOA problems, you will have lots of problems involving force of interest, and it's kind of not as intuitive as the annual compounding is. Therefore, I'm spending 2 lectures on it. Okay. So let's see. This will be 100 e power, what's the integral of t squared by 100? T cube by 300. Okay, so T cube over 300, 0 to 3. So that's 27 over 300 minus 0. So that's 100 e power 0.027 equals,
Well, it's not 100, it's 300.
where's 300?
You divide by 100.
What? Oh, it's a 0.009 or 009. Okay, 0.09. 100 e to the 0.09. How much is that?
So we don't need the law.
We don't need what? Huh?
The law. But we do not do it.
Right, but look, the integral was this one. So do you agree that this integral is just the value? So forget about the e. What is this integral? Isn't it just e? Isn't it just 27? Okay, this integral is t cube over 300 from 0 to 3, which would be 27 over 300. So this integral is just 27 over 300. And that's the whole integral is sitting in the power of e. So it's e power 27 by 3. Yeah, these limits are not going on the e. These limits are just on this integral. So you just imagine that you have calculated this integral, and then whatever you get, you're putting that in the power of e. Okay, so what do we get? 100 e to the 0.09, how much is it? 109.42. Okay, so that is how much this 100 accumulates to by time 3. But then what's happening at time 3?
Make a non-investment.
You are making another investment of X. So now suddenly your account will jump from 109.42 to 109.42 plus X, right? After the investment X at time 3, the account value jumps to 109.42 plus X. And now for the next 3 years, from time 3 to 6, this is the amount which will now start growing from time 3 to 6, right? Because this is what you will now have at time 3. By time 6, this grows to. So now just think that this is the investment you have at time 3, and we are trying to find how much it will grow to time 6 at time 6, right? So now tell me that's the challenging part. That how much will, so this is what I have here. How much is it going to grow from 3 to 6? Again, we have force of interest going on. So this is like the principal, right? 109.42 plus X e power. What will be the time bounds? 3 to 6. of delta t. E power t cube by 300, 3 to 6. E power 6 cube over 300 minus 3 cube over 300. So what's this number? What is this number? E to the
189 divided by 300.
260.
0.63.
Yeah, so it'll be e to the 0.63, right? So what's e to the 0.63? 1.88. Okay, so this is the situation. So I can distribute it. So what's 109.42 times 1.88?
205.44.
Plus 1.88x, right? So now I have both the amounts. I have the amount at time 6, which is this one. And I started from which amount at time 3? This one. And so the interest from 3 to 6 will be the difference of these two, right? So interest from t is equal to 3 to 6 is, and now they tell us that that interest is x. They say the amount of interest earned from time 3 to 6 is x. So x is equal to the difference at the amount at time 6, which is 205 plus 1.88x minus the amount at time 3 from where we started from 109.42 plus x at time 3. Okay. So this can be simplified. X is equal to, so when you distribute the negative, 205.45 minus 109.42 should be 106.03. And the 1.88x minus x will be 0.88x. And then we have x minus 0.88x equal to 106.03 and 0.12x. So x would be 106.03 over 0.12.
I got 96.03 and not 106.13.
Oh yeah, right. 205 minus. Okay, yeah, that's 96.03. Very good, very good. 96. Okay. And that should be 800, isn't it? So yeah, I think this is a slight variation of the one which we have on SWA now. but that uses exactly the same ideas. There, instead of saying interest from 3 to 6 is X, I think that they say that the final amount is X. Calculate the interest from 3 to 6, something like that. So after doing this, you are very well placed to tackle that one. Okay. So that was number 11. And then let's look at number 15. Tony makes a deposit into a bank account which credits interest at nominal interest rate of 10% per annum, convertible semi-annually. At the same time, Fabio deposits 1,000 into a different bank account, which is credited with simple interest. At the end of 5 years, the forces of interest on the two accounts are equal, and Fabio's account has accumulated to Z. Determine Z. Okay. So first, let's see what happens, what is Tony's amount. So Tony So they don't tell us how much Tony deposits, right? They just say she makes a deposit. I don't know if it's a he or a she. Doesn't matter. Nominal rate of 10% per annum. So we want to see what happens after 5 years. Because at 5 years, the forces of interest on the two amounts are equal. So A of T, we don't know what her principal is, and the interest is, so the general formula is P times 1 plus IM by M, right? MT, right? That's our generic formula. And in this case, it would be 1 plus IM in this case is 10%. And what is the M? 2, the semi-annual, so twice a year, so 2 times T. So 0.1 by 2 is 0.05, so P times 1.05 power 2T. Now, what is the force of interest? I gave you a formula for force of interest. The force of interest for Tony is, tell me, I gave you a formula for delta T.
AT is the derivative over AT.
A prime T over AT.
Yeah.
Right? I gave you that formula. So that's going to be used. A prime T over AT. So what's the derivative of this? P is a constant, so you keep it. And what's the derivative of 1.05 power 2T? Calc 1 skills. Now, first of all, it looks like the power rule, but is this the power rule on the 1.05 power 2T? Why not? In the power rule, the variable is in the base and the power is a constant. In this case, the base is a constant and the power is variable. So what rule do we have then? It's like a power x, isn't it? So what's the derivative of a power x? A power x ln a. Recall. Okay, let's write it here. Recall. The derivative of a power x. So you know derivative of e power x is e power x. Now, if it's not e power x, but a power x, any other constant, then in general, the derivative is a power x ln a. Does it ring any bells? You don't do this much a lot, but we do a few problems with this in tough one. So it's not really expected that you know it from the top of your head, but I think after being reminded, some bells should ring. Bells are not ringing. That's not a good sign. But that's not a good sign as far as calculus is concerned. I mean, still, that's even in the formula again. Okay. So now tell me, what will be the derivative of this p? Okay, p is a constant, so what's the derivative of 1.05 power 2t? Using this rule.
It's 1.05.
First of all, you just repeat it, 1.05 power 2t, and then ln of the base, ln of 1.05, but are we done? We're not quite done, because this is the rule if you have a power x. So what if you have a power 2x? Then you will have a power 2x ln a, and then my chain rule, the derivative of 2x, which is 2. So the derivative of 2t, which is 2. So let's write it here. Very nice shake up of Calc 1. Chain rule. What is this? This is not power rule, but you can say exponential rule. No. What's that other function called? Exponential function rule. But not the e power x, but a power x. Okay. So that's the derivative of this, and in the denominator you just have the a of t again, p 1.05 power 2t. This cancels, p cancels, so it's 2 ln 1.05. How much?
0.975.
Point?
0.097.
0975. Okay, now since this was compound interest, although it was compounded at semi-annual, the force of interest has come out to be constant, which will always happen for compound interest, no matter how often the compounding happens. So the force of interest has come out to be 0.0975 at any time t. We are just interested in the force of interest at time 5. So in this case, it will be the same even at time 5. So the reason I'm writing this delta 5 is that for the other one, since it's simple interest, so there you will see that the force of interest is going to come out a variable and not like a constant over here. And we want it at time 5. So that's why to match that, I've already written this one also for time 5. So what's the name of the guy? Fabio. Fabio. So what's happening to Fabio? Fabio deposits 1,000. So what's the amount of Fabio? A of t equals P 1 plus IT. Remember, Fabio is simple interest. So equals, actually, I don't even care if he deposits 1,000 or whatever, because this is going to cancel out. See, the principal always cancels out when you do force of interest formula, because whatever the principal is, it's just going to appear again in both numerator and denominator and going to cancel. So they didn't even have to say it's 1,000, it could have been even untold. So, but okay, let's just write 1,000. And are we given his interest? No, it just says simple interest. So that's pretty much it. So delta T for Fabio, force of interest for Fabio is delta T is equal to again A prime T over AT, the generic formula. Okay, now what's the derivative of this one? The P is a constant. And what's the derivative of 1 plus IT with respect to T? I? Now you see, it doesn't matter what the principal was, it's going to do. And I think we did that for simple interest as well in an earlier example. That for simple interest, the force of interest comes out to be I over 1 plus IT, but you just see that even if you don't remember that, it just takes 2 lines to derive it. Okay, so now we are interested in the force of interest at time 5, right? Because at time 5, we are told that they are equal, the forces of interest. So we put T equals 5, so 1 plus 5I. So now we set the 2 equations equal, setting the 2 forces of interest equal. So we have I over 1 plus 5I. The other one was 0.0975. And we solve this for I. So first we will multiply. Distribute. 5 times 0.0975. 0.4875.
4879.
48.
0.487.
79?
Yep.
I don't believe that. 1975 times 5 can't end in a 9. 4875.
475, yes.
Okay.
So that's a bit good.
I minus 0.4875I. 0.0975. So this is 0.5125I. Why are we calculating this I? Look, what is the question asking? Z, and what is Z?
Fabio's account.
Z is Fabio's account, and Fabio's account does have that I in it.
Yeah.
So we do need it. So what do we get? 0.19 exactly?
No, 0.19024.
Oh, that's okay. So 0.19. So I is 0.19. And so Z is Fabio's amount. So that would be 1,000. 1 plus 0.19 times 5. Second, right? So now we do need this 1000. $19.50.
So you are using the simple interest formula, not the force.
No, for Fabio, it's simple interest. Fabio deposits 1000, which is credited with simple interest. And the Z is Fabio's amount. So for Fabio, it's simple interest always. So is this what they have at the back? 1950?
1950.
How much?
1950 to 75.
Is it because of this rounding? So they have 1952. So try this rounding. The 0.0975 divided by 0.5125 and substitute that over here. No?
We rounded a lot.
Where else should we
It gets
round?
close.
How much does it get?
It's 1951.22
So I think we rounded this also, the 0.0975.
and Tawny's.
And which one?
Tawny's stuff.
What did we round in Tony? Oh yeah, this one. This one we rounded. Until then it's exact. And then this one is rounded, the 0.0975. So I think that this is the rounding that's causing it. You can just make sure. So instead of 0.0975, use this 2 ln 1.05. So over here, use 2 ln 1.05. And that should land you the exact 1952. So now what do we get? What is 2 ln 1.05 over 0.5125?
109,758.
0.09? I mean, it should be around this.
No, dividing by. I mean,
Yeah, divide by 0.5125.
Point 1904.
Okay, 0.1904 times 5.
0.9520 plus 1
Yeah,
times 1,000. 1952.00.
Yeah.
So you are off 75.
you're still off 75 cents?
Yeah.
You got 75? Okay. Okay. So that was 15. And now let's look at beautiful, number 36. Look at that. Calculate the ratio I3 over delta 2. 36. So, remember from very early on, how do we get I3? Remember, I3 is the interest rate during the third year. So do you recall this formula for IN? What is it? AN minus AN minus 1 divided by okay. So I3 will be A2. No, A3 minus A2 over A2. Okay. Good.
How do you figure it out that you need to use these effective interest rates?
Because they want the ratio I3 over delta 2. So I'll calculate I3 and I'll calculate delta 2. And then, so for I3, I know I have this formula. So A of 3 will be what? 3 square plus 3 plus 2.25 minus A of 2 is 2 square plus 2 plus 2.25 over 2 square plus 2 plus 2.25. So what do I get? 9 plus 3 is 12, 14.25 minus 6, 8.25. So that's a 6 over 8.25. Six over 8.25. Why not?
That just messed up.
How much? Don't round too much. 6 over 8.75. So that's what? It cancels by 3. So 3 over 8.25. Okay.
It is 0.7272727.
Oh, 0.7272 forever.
Yeah.
Okay. Okay. So I think this much. Good. So that's I3. And now how do we get delta 3? What's the formula for delta T? A prime T over AT. So A prime T is 2T plus 1. AT is T square plus T plus 2.25. And now substitute T is equal to 3 to get delta. No, delta 2. Delta 2 is what way? One delta 2. So delta 2 would be by substituting T equals 2. So 2 times 2 plus 1. 2 squared plus 2 plus 2.25. Five over 8.25. Actually, we could have left this as 6 over 8.25 because we have to take the ratio. So we want I3 over delta 2. So that means 6 over 8.25 divided by 5 over 8.25 equals 1.2. Okay. So that finishes force of interest. And I think now we are good experts at it. Let's go to the next section. So So what does it say in syllabus? What's the section we have to do after section 10? Actually, section 11 is a nice continuation because the first problem I see is about force of interest. So let's do number 2. Okay, find the accumulated value of 1 at the end of n years if the force of interest is delta t. So what's the generic formula for the amount with force of interest? P e power integral 0 to t delta t, isn't it? So we want the, so here time is n years, so a of n, and principal is 1, e power 0 to n, and the force of interest is 1 over 1 plus t. So what's the integral of 1 over 1 plus t? ln 1 plus t, ln 1 plus t. Right, remember integral of 1 over x is ln x, and if you do the use substitution, you get ln of k plus x is equal to ln of k plus integral of 1 over k plus x is ln of k plus x. So this is e power ln 1 plus n minus ln 1 plus 0. What's ln of 1? 0. And what's e power ln 1 plus n? 1 plus n, because e and ln at different levels cancel out. Amount at n is 1 plus n. What? Nice. What happened? Nothing? You're just mesmerized by the answer? Right. So if you have e and ln at different levels, they cancel out and the exponent comes down. That's a fact from pre-calculus. Okay. So then let's look at number 4. So if delta t is 0.01 t, time between 0 and 2, find the equivalent annual effective rate of interest over the interval 0 to 2. So number 4. So one way to do it is, so normally, actually I gave you a formula last time of conversion between annual effective rate and force of interest. What was it? Was it I is equal to e power delta minus 1? Remember, I gave you delta is equal to ln 1 plus I, and I is equal to e power delta minus 1. Oh, Christian, where's your mask? My God. Oops. Don't show me where it's. You're doing everything wrong today.
I'm tired.
Didn't bring your calculator, not wearing a mask.
I don't have to- got my keys, my phone.
Okay. So, um, so yeah, so why can't we use that formula in this case? So what was the formula for I? I was e power delta minus 1, right? Now remember, very important, those conversion formulas are for compound interest. And that those apply if the force of interest is constant, because you know that force of interest is constant only for compound interest. In this case, is force of interest constant? No, it has a t in it, so 0.01 t. So this time we're not dealing with compound interest, and therefore those formulas don't apply anymore, right? So one way to find the annual effective interest rate, so basically we want to see which interest rate corresponds to this delta t. So one way to do it is, let's see what happens to a certain amount. Which amount do you like?
One.
Which principle do you like? So let's say 1. Okay. So if p is equal to 1, it grows in 2 years under the force of interest to, so 1 times 0 to 2, no, 1 times e power 0 to 2, right? Delta t dt. Agreed? Because it's p e power 0 to t delta t dt. So that's equal to e power 0.01 t squared by 2, 0 to 2, 0.01 by 2 times 2 squared is equal to e power 0.02.
One question.
Yeah.
In the wording, you have P of t equal to, not equal, it looks like a minus.
Yeah, it's equals.
Okay.
Okay. So we agree that 1 grows to e power 0.02. So how much is e power 0.02?
1.02.
1.0202. Okay, very good. And now the question is to find the equivalent annual effective rate. So let's see how much this 1 grows under an annual effective rate in these 2 years, right? If I is the annual effective rate, is the equivalent annual effective rate, then 1 grows in 2 years to, so tell me how much does 1 grow under an interest rate, annual rate of I? 1 plus I squared, 1 times 1 plus I squared, that's compound interest. Remember the formula, P 1 plus I power t. Let's write the formula over there also for the force of interest. P e power 0 to t delta t dt. So we agree that under annual effective rate of I, it will grow to 1 times 1 plus I power 2. Yeah. And to find the equivalent rate, they should grow to the same amount. So basically, when they say find the equivalent annual effective rate, what this is saying is that find the annual effective interest rate so that it grows to the same amount as it would under the force of interest. That's when you can say that, okay, this annual rate is equivalent to that force of interest because my principal of 1 grew to the same amount under both types. And the principal didn't have to be 1, any principal would give you the same result. So we want to see 1 plus I square is equal to 1.0202. And that will give you the equivalent annual effective rate. So take the square root. Then subtract 1. So what do we get? 0.01. So 1%. So this force of interest is equal to an interest rate of 1%. Really? Is that the answer? Okay. Yeah, that's quite surprising because somehow I'm looking at this 0.01 and that's also 1%. That's so can we make a general rule that if delta t is a multiple of t? No, but there is so much going on here because this is 2 years. What if instead of 2 years, this was 5 years? It would be the same, it wouldn't be the same thing then. So it just happened to be like this, that this 1% was matching exactly this one, this 0.01. Okay. So nice end. And like as we said, now we will meet every day until further notice. So we'll meet both Monday and Wednesday. Yeah.
One question. So you said that we cannot use the formula that you gave us before, which relates delta and I, because
No, we cannot because
these are not both.
right, that one is used for constant delta. This one is a variable delta.